Hi everyone, welcome to my YouTube channel. Dr. Samson Chukwedo here again on Research Statistics Mind tutorial. Let's discuss the forms of reliability in quantitative research. To understand these aspects of the lesson properly, let's start with its introduction. If you have two kids and you send each of them out for a piece of information, and one always return with information that you can trust, but the other return with information you cannot depend on. The question you ask yourself is any of these two kids reliable? Of course, you say the first one, or the one of them that return with information that you can trust is reliable, while the other is not reliable. The same applies to our research findings. One important aspect of our research findings is the dependability or the trustworthiness of the results obtained from such a study. That means to establish high level of trustworthiness of our research findings, the measuring instrument must equally possess the property of dependability or trustworthiness. If the instrument used to collect the data is not trusted or it cannot be depended upon, it means the results cannot equally be depended upon. That means the property of dependability or trustworthiness is simply called reliability in its general term or even in research. What then is the meaning of reliability in research? Reliability is simply the degree to which a measuring instrument consistently measures whatever it is measuring. This word, consistently, could mean that the instrument should be able to be used in a particular study to measure a given construct. At the same time, in another study, it will still give the same result, where such an instrument could not do the same in the two studies. You cannot say that the instrument is reliable. Yes, in my previous video we have learned validity. In as much as validity tells us the appropriateness of a research instrument, reliability actually evaluates the consistency of the scores obtained from the instrument. Take note that an instrument may be valid, but it may not be reliable. The reverse is not usually the case. Hence, reliability from the definition we have done is often expressed numerically, and the value ranges from 0 to 1. You cannot have a reliability value that is less than 0 or that is more than 1. Now, having seen the meaning of reliability, let's look into the different types of reliability. That is the core aspect of this tutorial. For you to choose a given type of reliability, it may depend on the number of times the instrument will be administered. Usually 1 or 2 times, which are easily used. When it is 1 time, there are types of reliability that can be employed. If it is 2 times or more, there are other types of reliability or forms of reliability that can be employed. The choice of a type of reliability can also depend on whether you are evaluating the person's agreement, that is the individual's agreement, or that you are evaluating the item's agreement. So having seen that the choice of a type of reliability depends on number of administration and agreement you're evaluating, whether as per the persons or the items, we have different types of reliability. The first type listed here is called stability form type of reliability. It is sometimes or often called test-retest reliability. Another type of reliability here is the equivalent form reliability, which is also called alternate form reliability. Another type is the combination of stability and equivalence. That is why it is called equivalent and stability form reliability. Then we have the internal consistency reliability. And finally, the one here is scorer or rater reliability. These are the commonly used types of reliability used in research. However, let's note that each type of reliability may have one or more approaches to adopt. For instance, internal consistency reliability does not have a specific approach of calculating it. It has even more than 3 or 4 approaches. So no matter the type of reliability you have, it could just be one approach of conducting it or more than one approach of conducting it. I am not going to do detailed discussion on the approaches here or how it is done, but we're going to conceptualize them. I'm going to release a future video on each type of reliability, on how you conduct them individually. Having seen the different types of reliability, let's discuss them one by one. The first one here is the stability form of reliability, which is test-retest reliability. It simply tells us the extent to which the scores on the same test or instrument are consistent over time. That means you are measuring scores of an instrument more than one time. It involves giving one group of persons the same instrument or test at 2 different times, and then you correlate the 2 sets of scores obtained from the 2 times. This type of reliability is therefore an evaluation of 2 scores of individuals about an instrument. That means it tends to evaluate scores of individuals, not really the items of the instrument. In doing this to obtain the 2 scores, the time interval between the first and the second test or your administration has no generally accepted rule of thumb, but scholars have agreed that between a period of 2 to 6 weeks will be okay to collect such 2 scores. In having collected the 2 scores, for you to calculate your reliability, the statistic that is often employed is bivariate correlation. An example is the Pearson's product moment correlation coefficient, which is the PPMC. Let's look into the second type enlisted here, which is the alternate form reliability, or you call it the equivalent form reliability. It is the degree to which 2 similar or equivalent forms of an instrument are consistent. Remember, in test-retest is just one particular instrument that is administered twice to a group of persons. But here, 2 equivalent forms of an instrument are administered to a group of persons. So it aims to establish the relationship between 2 versions of a research instrument that measures a particular construct, and these versions of a research instrument are intended to be equivalent. For instance, you may have a construct like self-efficacy, where you have 2 versions of instruments that tends to measure self-efficacy. When you want to establish the reliability of the 2 versions, it is called alternate form reliability. The 2 versions of the instrument are actually similar because they measure the same construct and they have the same number of items, the same level of difficulties, the same scoring pattern and interpretation. However, these 2 forms of instrument, they differ in their wording of the specific item. That means the content of the specific items will differ, but that doesn't mean that they measure different constructs. Having done this, the method involved in administering the 2 versions of the instrument is to administer it once to a single group, but at the same or almost the same time. That means the 2 versions of instrument can be administered to a group at the same time or just almost the same time, where a short time elapsed in between the first administration and the second administration. Having done the administration and collected your data, the two sets of scores obtained from the two versions of the instrument are statistically correlated using bivariate correlation, just as in a test-retest method. All right, another interesting type of reliability or form of reliability is equivalence and stability form reliability. As the name implies, it somewhat combines the equivalent form and the stability form. As the two names goes in that order, it combines it. That means you need to have two different forms of instrument and also apply the test-retest method of reliability. That is why we say that equivalent with stability form reliability is aimed at establishing the relationship between equivalent versions of an instrument which is administered to a given group at two different times. But during this administration, the one version of the instrument is administered at a time, while the other version is administered at a later time. So you can see that equivalence is that you use two versions. Stability is that the two versions are administered at two different times. Take note, when we discuss test-retest reliability, we've been able to establish that times of 2 to 6 weeks is suitable. The same applies in equivalence and stability form reliability. Just as in the equivalent form reliability we discussed earlier, the two versions of the instrument are similar based on the conditions that I have discussed in equivalent or alternate form reliability. Now, having obtained the scores from the two different times with the two different versions, the bivariate correlation is often the statistics that is being used to compute the reliability coefficient. One widely form of reliability often employed in behavioral research is the internal consistency reliability. It is the degree to which items of an instrument are consistent about themselves and with the total items of the instrument, that is, with the test as a whole. In this type of reliability, it measures the extent to which the items are similar to one another in content. This type of reliability is often used in many behavioral research or even educational or social research. In doing this, it involves administering the instrument once to a single group of persons and then apply any of these following methods. This type of reliability does not have one specific method, so there are different methods you may apply. One of them is the split half reliability. Another one is the Kuder-Richardson reliability. The Kuder-Richardson has two forms, which is the KR20 or the KR21. Then Cronbach's alpha reliability can also be applied to measure internal consistency. And then McDonald's omega reliability can be applied, and many more. There are very many of types of reliability that can be applied to measure internal consistency. Just to mention a few of them, the Revelle's beta approach can be used, or the greatest lower bound approach can be used to establish internal consistency of an instrument. All right, having seen the list of the approaches we can use to measure internal consistency, let's just briefly discuss a few of them here. First is the split half reliability. Just like we said earlier, all internal consistency measure method involves just one administration. But in split half, after administering the instrument, the researcher is expected to split the scores into two equal halves. Usually, splitting scores into odd or even items is often preferable. Then, having done this splitting of the scores into two equal halves, you correlate the two sets of scores and apply Pearson's product moment correlation coefficient. And having applied that, the R value you obtain, use the Spearman-Brown's correction formula to improve on the result. I'm not going to discuss the calculation method here, nor show how to do it here. Take note, it can be done manually, and you can use SPSS to do that. In my future video, each type of reliability, I'm going to discuss them and then show you how to calculate them, that is, compute them, either manually or the use of statistical software such as SPSS. So, having seen the split half, another one among the internal consistency reliability is the Kuder-Richardson reliability. This is applied to only dichotomous response options, that is, instrument that has two response options such as yes or no, agree, disagree, 1 or 2, as the case may be. You may even have test items used to measure students' performance that is objective test. One answer is right, others are wrong. They fall under this Kuder-Richardson reliability. Like I said earlier, Kuder-Richardson reliability has two types, KR20 or KR21 formula. KR21 formula is just a simplified form of KR20 formula. So, having administered the instrument, apply the KR20 or KR21 as it suits you in your research. Now, the next type is the Cronbach's alpha. This has been widely used in research. Cronbach alpha is sometimes called the tau equivalence reliability. It is applied when you have a response option that is more than 2. That is polycotomous response option. For instance, strongly agree, agree, disagree, and strongly disagree. That is a polycotomous response option. After you might have administered the instrument, then apply Cronbach's alpha formula. Like I said earlier, it can be done manually or with the use of statistical software such as SPSS or even Stata. Another add-on to XPSS has been developed where you can do this, which is Andrew Hayes macro can be used to do such a calculation. Now, another interesting and more trending one now is the McDonald omega reliability. It is almost the same as Cronbach's alpha. In my future video, I will still discuss the difference between the two. They are very closely related, but you simply apply McDonald's formula instead of applying Cronbach formula. Researchers have argued that McDonald's omega reliability is superior to Cronbach's alpha in that the issue of tau equivalent, which is a requirement in calculating Cronbach alpha, is just a theoretical assumption in Cronbach alpha. The McDonald's omega solve the problem of that theoretical assumption. But let's just know that McDonald's reliability is very closely related to Cronbach alpha, but the formula are different. Now, having discussed the different other types of reliability, one important type of reliability, the scorer or rater reliability. In the previous types of reliability we discussed, it has to do with participants themselves rating the items by themselves. But here in scorer or rater reliability, there are scorers, judges, or you may call them individuals who rate whatever is observed. Let's discuss scorer reliability. It is simply defined as the degree of consistency of subjective scores about a subjective instrument. And that means those scores were either obtained from 2 or more raters at a particular time, that is at one time. That means it is called intra-rater reliability. The scores may also be obtained from one rater at 2 or more different times. It is called intra-rater reliability. That makes it 2 types of scorer reliability. However, take note, that the scores are subjective, or that the instrument you use to collect the data is a subjective instrument. An example of subjective instrument or subjective score could be observations when you expose someone to performing a practical skills. You need one or more judges to rate the performance of such a person, or you need a judge to rate the performance of such a person at different times. Even when we score students about essay test, it is a subjective score. The test itself is a subjective instrument. So take note, we have two types of scorer or rater reliability: the inter-rater reliability and the intra-rater reliability. So let's discuss the two types of rater reliability as quickly as possible. While inter-rater reliability is often called the between-rater reliability, it evaluates agreement on how consistently two or more independent raters can assign the same score to a measure or a behavior at a particular time. So they observe a behavior once and assign their independent scores. It is called inter-rater reliability. On the other hand, we have the intra-rater reliability, which is often called the within-rater reliability. It evaluates the agreement on how consistently the same rater can assign a score to a measure, a behavior, or a test at two or more different times. So if you expose someone to perform a practical skill and ask a rater to rate at one time, and then the person repeats the practical skill, the rater rates at another time, that is simply called intra-rater reliability. So there is a difference between inter-rater and intra-rater. Observe that from our definition. Now, I haven't done whether intra-rater or intra-rater to get the reliability coefficient. You're going to apply a statistic. The commonly applied statistic here is either Spearman-Rho statistic is applied, and that's why some people say it's a Spearman-Rho method of reliability. It could be Cohen-Skepper reliability, which means it's a statistics you can apply. And then the Krippendorff's alpha method of reliability can also be applied, and the intercorrelation coefficient reliability can be applied. Now, the Krippendorff's alpha reliability is a very robust way of calculating reliability in scorer or rater reliability, because it takes care of both nominal, ordinal, or continuous data, while others are applied at a given type of data. But Krippendorff's alpha method can be applied whether the data is nominal, ordinal, or even continuous data. It also takes care of missing data in computing reliability. Alright, so far we have discussed the different types of reliability. I promise I'm going to come with a future video on how to calculate or compute the different types of reliability using the different statistical software. Right, so let's go to the puzzle as quickly as possible. The puzzles are, the first one is, what is the difference between intra-rater reliability and test-retest reliability? Another one is the difference between alternate form reliability and equivalence with stability reliability. What about Cronbach alpha and McDonald reliability? If you have any confusion on all this, go back to the video, you're going to get it. Another puzzle is, can an instrument be reliable but not valid? When do you apply a given type of reliability in your study? Before I'll go, I'd like to say, please subscribe to my YouTube channel if you have not done so, and try to click the thumb up button to like this video if you actually like this tutorial. It's a very good way for YouTube to recommend my video to many persons. Then try to make comments wherever you have issues about this video, or wherever you want contribution about the video. Continue to watch this video, and don't fail to share the link to different persons in different platforms.